Hello, everyone, and welcome back to another session in our numerical method series. And in today's video, we will explore the working rule of the secant method, an elegant and powerful algorithm used to find the roots of a nonlinear equation. So, all without needing the derivative. So, let's get into the step by step logic, the math, and the strategy behind the amazing technique. In many mathematical models and engineering problems, we encounter equation of the form f of x is equals to 0. So where we cannot solve the equation algebraically, that's when we turn to iterative numerical methods like bisection method, Newton-Raphson method, and of course the secant method. So the secant method is specifically useful, number one, when we can't compute the derivative of any function. Secondly, we need a fast and relatively simple method to find the root. Need a fast and simple method. So the basic concept of the secant method is that instead of using the derivative like Newton-Raphson method, the secant method uses two initial approximations. So let's call them x0 and x1. These are two values where the function f of x is defined. So basically, we need to evaluate the function at these 2 points, that is x0 and x1, and then we draw a secant line through these 2 points on the graph of f of x, and the point where this line intersects the x-axis is our next approximation, and we denote it as x2. And that's the basic idea. At each step, we use the two most recent approximations to estimate the next one. So iteratively improving our guess of the root. So let's derive the very simple formula for our secant method, that a very simple derivation, just a 2 to 3 lines derivation. So a secant line passes through 2 points, and we call it x naught and f of x naught. And second point, we have x1 and f of x1. So we call it that both these points has a slope, and we define it with m is equals to f of x1 minus f of x naught divided by x1 minus x naught. So using the point slope form of a line, we have y minus f of x is equals to, sorry, here we have x1 is equals to mx minus x1. So we set y is equals to 0 to find where this line intersects the x-axis. So we simplified it to 0 minus f of x1, that is equals to mx minus x1, and when we simplify it, we will get x is equals to x1 negative of f of x1 and x1 minus x naught over f of x1 minus f of x naught. So to set our next approximation x2 is or we just simply say that the generic formula for secant method is xn plus 1, that is equals to x of n, and we have negative xn, xn minus 1, and divided by f of xn and negative f of xn minus 1. So in this case, our n ranging from 1, 2, 3, and up to so on. Or we simply write this formula as x of n plus 1, that is equals to xn minus 1 f of xn minus xn, and we have f of xn minus 1 divided by we have f of xn and minus f of xn minus 1. So we have n starting from 1, 2, 3, and up to so on. So this is the iterative formula for a secant method. So let's move to the basic topic of today's video, is the working rule of secant method. Let's now break this into a working rule or an algorithm. So the step 1, we need to choose two initial guesses, and let's suppose we have the first initial guess x naught and the second one is x1, and that is close to our root. Second step is compute f of x naught and f of x1. Thirdly, we need to apply the secant formula. So we have xn plus 1, that is equals to xn minus 1, f of xn minus xn and f of xn minus 1 divided by we have f of xn minus f of xn minus 1. So here we need to just put n is equals to 1 in this generic formula, and we just shifted this generic formula into a customized formula. So it will become x2, x0, x naught basically, and f of x naught minus, sorry, it's not x naught, it should be x1, minus x1 f of x naught and divided by f of x1 minus f of x naught. In the fourth step, we need to update the values. X naught is equals to x1 and x1 is equals to x2. Now we need to repeat the step 2 to step 4. until the required accuracy is achieved. It means that you have the value of xn plus 1 minus x of n is smaller than preset tolerance, and you need to define the tolerance according to your choice. So say you have a tolerance of 10 raised to the power minus 5 or 10 raised to the power minus 4 or 10 raised to the power minus 3. That's up to your choice. So this is the basic working rule of the secant method. So this iterative loop continue until we get close enough to the actual root of f of x is equals to 0. So the closer the initial guesses are to be the actual roots, the faster the convergence. So the key characteristics or the most important points about this method you all need to know is important points. So number one is no need of derivative for this method. Unlike Newton-Raphson method, which requires a computation of a derivative, and this method only needs a function value, but not its derivative. That is the best part of this method. Secondly, super linear convergence. This is faster than bisection method, but slower than Newton-Raphson method, but this is also a good balance. Thirdly, this is sensitive to initial guess. So poor guesses are not guess initial guesses. So poor guesses may cause divergence or slow convergence. So it's better choose initial guesses wisely. And the last one is its efficiency. So for well-behaved function, it converges rapidly and with less computational cost. So to sum up, the secant method is powerful root finding technique that bridges the simplicity of the bisection method with the speed of Newton-Raphson method, but without requiring derivatives. So it's particularly useful when the function is smooth and continuous, and secondly, you can provide two good initial guesses. So if you found this video helpful, give it a thumbs up, subscribe to my channel, and share with your classmates. So thank you so much for tuning in. I'll see you soon in the next video. Stay blessed.